Hey guys, welcome back. Okay, so a couple things first off the bat. First off, forgive me if I sound a little bit off. I'm not feeling that great, so I'm trying to keep this fairly normal, but I'm really feeling pretty terrible. So forgive me if it's a little bit, out of whack. One thing I wanted to mention, because somebody brought it up. Somebody actually watched this video and asked me a question about this. You will notice that I will put my local variables up top. Now, there's a famous book. It's called 101 Coding Standards, something like that. Let me take a quick look at my bookshelf. C++ Coding Standards, 101 Rules, Guidelines, and Best Practices. This is a book by Herb Sutter and Andrei Alexandrescu. These guys wrote this book, and it's pretty much become, I guess you could say, industry standard. Everybody pretty much adopts all 101 of their little rules. And it's just standards. Like, they don't go over how many indents to do. The first thing they say is don't worry about that kind of stuff. Just do however you like, which is the same thing I said. But they talk about, how to format stuff so that it's easy to read and what best practices are. And one of the things they say is to define your variables as close as you can to the point in which you actually use them. So instead of doing what I've done here, what they'll usually do is, let's see if I've got where am I using these? Yeah, so like for instance, they would suggest you take window rect. This is not bad, and stick it down here. And why do they suggest that? Well, because take a look at this. What happens if you quit right here and you actually return? By doing your window rect down here, you're never defining window rect, and it's not slowing the program down by defining something that never actually ends up getting used anyway. And I understand all that. That's all great and well and fine. And I get it. I understand why people do it. However, in my opinion, I think that clutters the code. When you're starting to do stuff like this, like you're defining stuff down here at the same time you use them like that, it makes the code just that much more cluttered, right? It's a little bit harder to read. And to me, readability is everything. It's super important for your code to be readable. So I tuck them away up top. It's like the one rule of theirs that I don't agree with. I agree with, like, I think probably 95 of their rules or something like that out of 101. That's the one I don't agree with. And that's just me. You guys are welcome to disagree with me, and I think most people will. But I like to have it tucked away so that they're up here, they're out of my face, and I can read code instead of reading definitions. Okay, that's my justification for that. It is not standard practice because, again, everybody does it the other way. But that's the way I prefer to do it. I mean, and my background coming from where the programming languages that I learned, that's how you had to do it anyway. So that's just the way that I know how to do it. Another thing that I wanted to talk about real quick before we get into the meat of this episode is at some point pretty soon, I'm going to want to start thinking about defining some kind of standard about variables. Variables can come from three different places, basically. They can either come from local variables like these, they can come from parameters like such, or they can come from member variables like this one. It would be nice if we had some kind of standard to differentiate those without having to look in where they are. Right now there isn't. And what I'm thinking I may do, now I've seen people do various things with this. Some people have put underscores in front to define member variables. That's frowned upon because underscores in front is usually reserved for compiler variables. So I've seen people starting to do things like this, put underscores afterwards, or sometimes they'll put M underneath it. That's not bad. I don't really like the underscore thing. The M thing is okay. I don't hate that. That's maybe what I end up doing. Probably what I'll end up doing is, right now I'm using camel case, upper camel case for all my variables for the most part. So for instance, when there's two words to a variable like window rect, that's upper camel case because it starts with a capital letter and each word in the variable has a capital letter. That's called camel case. What I might do is for local variables, make it lower camel case, and for parameters, make it upper camel case, something like that. I'm not going to change it right this minute. And then I'll do something else for the member variables. I haven't quite decided what yet. So anyway, that's coming. That way that you can just look at them and know where your variables are coming from, whether they're parameter variables, local variables, or class variables. And that's important in some cases. So it's nice to be able to just look at them and know where they're coming from. So yeah, we'll do that at some point, maybe next episode when I've firmly decided what it is we want to do. Okay, so I've gotten through all the preliminary stuff. Let's talk about where we want to go with this next thing. We're going to start the memory manager. And I had to take a bit of a think about where I wanted to start with this, because it's a pretty big project, this particular system. And I thought about it quite a bit, which is why there was no episode last week, and decided really the first thing we want to do, the first thing we have to do really, is catch the new and delete commands, because those are the commands that actually run out to the operating system, grab some memory, and bring it back to you. And we don't want it to do that. But we still want to be able to use those new and delete commands just like you normally would, so that you don't have to do anything different when you're in the program, but we're going to override them. We're also going to overload them, to be honest, but we'll do that later. But we're going to override them right now. So what I'm going to do is go up to the game engine, and we're going to add a new class. And this is not where I want to do it. No, let's not do it there. I don't like that. Let's go to project, add class. This is what I'm more used to. Okay. And what we're going to call this is, we're going to call this the memory manager. Memory manager class. That way I can instance it later on. We're not going to so much work on the class itself, but this is a place to put our what we're about to do with the global variables. Okay, now, let me see here. What do I want to do with this? Let's go ahead and include our base here, because all of our header files should have that. So we'll have that. Okay, that's good. So ultimately, this is going to be the class that is exposed to the rest of the program. None of the other parts of the memory manager are going to be directly exposed to the rest. So it's really just going to be, this is going to be the interface class to everything else. Okay. But right now, what we want to do is talk about the new and delete commands that we want to override. So let's go to the control class, and we'll do some testing in here. Let's see. Yeah, we'll just do it up in here. So just some test stuff, remove after completed. Okay, what I want to do is put in the various flavors of new and delete. So let's go ahead and define a pointer, and we'll just call it P, because this is just test stuff. We don't need to have a descriptive name. So let's go just with the standard new. P equals new integer. And then we'll go ahead and delete that. And then we'll go ahead and define it again. That's just kind of your standard new call. There's another one that looks like this, which I think it's no throw. I think that's right. Int. No, it doesn't like that. Oh, sorry. I forgot to put the new command in. Okay, so that's because we have not yet defined new. So let's go to engine base, and we're going to include in a new include file, which is going to be called new. That's where all our new definitions come from. Okay. So back here at control window class, I'm working in create code. Yeah, that's fine. I mean, create control window is like one of the first things we could. I'm not really in the place where I want to be, actually. Let's take this out of here. This is not where I want to be. For testing stuff, we really should be in base. Just kind of this is the main function, right? So I'm just gonna stick it here, just so it's, up front. Okay, so there you go. So there's the regular new, there's the new with a standard no throw. So the difference between these is if this fails, it'll throw an exception. This will not throw an exception. All it'll do is it'll return a null pointer to P. Okay, I think this will also return a null pointer to P if it fails, but it also throws an exception. This won't throw an exception. Okay, So let's go ahead and delete that again. Then there's the next one, which you guys are probably aware of, new int with the array. And then we'll delete that. And then p equals same thing, new standard no throw int 5, and whoops, forgot the semicolon, and delete p. Okay, those are just your standard new and delete functions. There's another one, guys, and I guess I'll put it in here just for the heck of it, but I'll show you why we're not going to, well, I'll just put it in, and we'll talk about it later. So I'm going to create some memory. I'll just say memory of integers of size 5. It doesn't really matter. And then I'm going to say p equals new memory int. That's a placement new. That works a little bit differently than your standard news. So what this does is these guys all go out to the operating system, they get memory, and they return that memory address to you in the form of p, right? This placement thing, it doesn't go and create memory. It actually puts p at the start of memory and returns it to you. Okay, so if you already have your memory set aside, you can set p to that. Okay, so that's called the placement new. And you notice I'm not deleting it because we didn't create any memory with it. So yeah. Okay, so those are basically your basic forms of new. Yeah, I'll leave it at that, I think. Yeah, I don't want to make this too much more complex than that. Okay, those are the ones we need. Okay, so I can run this and it'll run just fine. It should run just fine. To be honest, the compiler might just optimize those out because they're not doing anything, but okay, so yeah, we'll assume that it's newing them and deleting them along the way. Okay, guys, so now we need to catch these. So let's go to the memory manager class on the H file. Now outside the class, I'm going to start catching these. So I'm going to say global override for new and delete operators. And we'll start going through the various flavors of these. So the first kind of new is the standard new. So void star operator new. Then we need from the standard library, we need a size t. And we'll just call it size. Okay. And then what's this problem? Oh, not found. Yeah, that's fine, because I haven't defined them yet. Then we'll do the second kind. Same thing. Operator new standard size t size, and then I'll make this a constant standard. Geez. No throw -t. I think that's how you do that. I didn't put the second colon, and that's why it's not having any luck. Okay. That should be... What's the matter with you? Not size of. Size t. Thank you. Thank you. That's what I want. Okay. Okay, so that's that second kind with the no throw. Now there's a third kind of function that we're going to take a quick look at. Standard size t size, and then void star p for pointer. Okay, and that's the placement one. That's the one we did here. That's the placement operator. Okay. All right, and I'm just going to do all of these, and it's going to look pretty intimidating at first, but don't let it freak you out, because I'm going to show you after an episode or two why it's not as bad as it looks. So I'm going to copy all these, and I'm going to paste them down, and we're going to do the exact same ones except with the arrays. And I think that should take care of it. Yep. All right, so those are your 6 flavors of new. You got the regular new, the no throw new, the placement new, and then the same ones for the arrays. Okay. All right. So let's talk about the deletes. Same thing for the deletes. The deletes don't return anything. Operator delete. And this is going to have the pointer. So that's just your regular delete. Then you'll go void operator delete. Then you need the pointer. And you need the constant standard no throw t reference. And then you also need the void operator delete. I'm not sure about this one, guys, actually. Let's find out if this works. What would be the... I guess it would be void... I think this may error on us, because I don't think there's any such thing. Yeah, there's no such thing as the placement delete. But I'm going to leave it in for right now. I guess that's what the syntax would look like if there was such a thing, but there is no such thing. So, but we'll put it in just for the moment, because I want to be consistent across all of these. Okay, so same thing with the arrays. All right, there you go. Now, of course, that's not going to compile because of those spurious deletes. So, okay, let's talk about this for a minute. So why is there no such thing as a placement delete? Well, remember what I said back here in WinBase. This doesn't actually allocate any memory. So if it doesn't allocate any memory, there's no need to delete it, right? So you're going to be using a new, but you're not going to actually delete because it's already existing as a local variable here. And when it goes out, when this local variable goes out of scope, it'll automatically clean up after itself. You don't need to delete it manually. So there's no such thing as a placement delete. So let's go back here so we can get rid of those. So yeah, look at this, guys. There's 1, 2, 3, there's 6, there's 12 of these. It's pretty intimidating, right? And these are complicated, but right away we've just gotten rid of 2 of them. So let's get rid of those. Okay, now if I try to run this, I suspect it's going to linker error on me. Actually, we just crashed. Something crashed. I don't know why it crashed. Okay. I guess it didn't. Okay. All right. We'll leave it at that then for right now. For right now, we'll leave it at that. Okay. So it works. It works fine, except for we had a spurious crash. I think that was a compiler problem. There's no errors. Everything works fine. It's still doing the new and delete. Now it's giving me warnings here because it's looking for function definitions and not finding them. So what's actually happening is it's falling back to, where's my base? Right here. It's falling back to the new, where those function definitions, or those function definitions actually live. Okay, so let's go back to Memory Manager class. I'm going to grab all these, copy them, come into Memory Manager class, bring them down here, and paste them in. And let's just start setting these up. I'll just set them up as functions. So the first thing I got to do is get rid of the semicolons on the end. And then I'll put in the ellipses, and I'll just copy these. Hey, what's going on here? Stop that. Fool of a took. Now it's screwing it up. Why are you doing that? Quit it. There we go. Well, it's completely destroyed. It's destroyed my thing. Let me see if I can get it to fix. What's the command? I think it's Control K, Control R. No, never mind. I don't want the object browser. All right. I've forgotten what the keystrokes are to auto fix those. I'm not sure it would work anyway. So let's just fix these manually. I'll have to look that up. Okay. So first of all, let's get rid of the ones we don't need. These two right here. All right. Okay, so let's go ahead and grab these. I'm just going to grab some separators and throw these in here real fast, just to make myself happy. Why are you doing that? Something there is weird. I'm just hitting Control Z to push it back to where it was. The compiler, for some reason, is pushing these out. It seems to have a spurious connection. Anyway, okay. So there you go, guys. We have all of our function definitions. Now, if I try to compile this, I'm just going to separate these a little bit. If I try to compile this, we should get an error. Let's find out. We should. Yeah. Okay, so we got an error. Function void operator new size t void star throw already has a body, and it's pointing at this guy right here, which is our placement new. So what does that mean? Why are these okay, but yet I'm getting errors with this one and probably the other one with the array? It turns out that the standard says you can override new and delete for the most part, but you cannot override the placement operators. And if you think about it, that makes sense, because what is this really doing? Why would this is not grabbing memory? It's taking this pointer and sticking it at the start of this thing. There's no reason to override this. We don't need to override it. It's not going out to the operating system. You don't want this to do anything other than what its default behavior is anyway. So the standard says don't do that, and they enforce that by having a body inside the, I think it's inside the new, or a subclass thereof, something connected to it. So we don't need this, is what I'm trying to say. So we'll take that one out, and we'll take this one out. And so we can go into here where the placement news are, which is this one, and delete it. And also this one, and delete it. And I'll take out these guys as well. So look at this, we're down to 4, 6, we're down to 8. We were at 12, we're down to 8. So see, it's not as bad as it looks. Okay, so now we really do need these. We need the regular new and the no-throw versions, and the array versions of both of those, and then the corresponding deletes. So we should be able to run this, and it'll run fine. Now what's going to happen here? I've defined these, but I didn't put any code in them, right? So the compiler is very gladly going to go ahead and run this, and it's going to use our new functions, which I'll show you guys in a little bit. but they're not going to work. If you're expecting to get something in P, you won't, because I didn't put any code in there. And in fact, actually, I take that back. This isn't going to compile. Yeah, because we got to return a value. So let's get it to compile before I do anything else. I'm going to do something here that is illegal, but it'll make the compiler happy. So we'll put in an int p, and we'll just say return reference to p. Okay, that's probably going to give me a warning, I'm sure, if I try to compile this. Let's see if we get a warning. Yeah. So returning address of local variable, returning address of local variable or temporary. Obviously, you can't return a reference to a local variable, because that local variable won't exist once it returns out of this function, right? This goes out of scope and it destroys itself. So obviously, this is not going to work, but it'll make the compiler happy. I mean, I'll get warnings, but for right now, I don't care. So I'm just going to drop these in here. Let's put that back. I don't need to worry about the deletes. This should give me warnings, but it shouldn't give me any errors. There you go. So I should be able to run this. And again, now, okay, so is that going to cause us any problems? It shouldn't. We're going to return a reference to something that's destroyed, but we're not using it for anything. Unless the delete causes it problems. I don't think it will. Let's see if it crashes. No, it doesn't crash. Okay. I mean, sure. So yeah, there you go. We just made the compiler happy. I don't want to go through the process of sticking code in here right at the moment. All I really want to do is get these captured. Now, at this point, we really don't have any way of knowing for sure that we're actually caching these, because for all we know, it could be calling the original functions, right? We don't really have any clear idea. I can tell you that they are being called, but let's prove it. Let's go ahead and prove that. So I'm going to put in here output debug string. I'm just going to put a debug string in here, and I'm just going to say new. We'll just call this new one called, and we'll put in a line feed. New 2 called. New 3 called. Or I'll say new array 1 called. That way we can distinguish it. That's fine. And new array 2. Okay. And then for the deletes, we'll do the same thing, except I'll say delete. Let's copy. Hey, stop that. Let's copy that, and we'll do the same thing here. And I'm going to show you something interesting that happens, guys. And those of you who know anything about news and deletes probably were thinking this the whole time, going, hey, what are you doing? This is not going to work. I mean, it's going to work, but it's not going to do exactly what we expect. Okay, there you go. Now, let's see, did I, let's go to my WinBase. Yeah, okay. Let's run that. Let's just see what happens. Let's prove that we're actually calling our functions and it's not going back to the default functions, just to prove it. And there's our window, and we close it out, and there you go. New 1 called, delete 1 called. This corresponds to these first 2. Then new 2 called, delete 1 called. This corresponds to these 2. New array called, delete array 1 called. That corresponds to these guys. And new 2 called, delete 1 called. That corresponds to these guys. Now, what just happened there? Why did we not call delete 2 ever? I mean, we clearly called new 2 right here, right? But we didn't call delete 2, we called delete 1. You think, well, okay, maybe what I want to do is come up here and maybe I'm using the wrong syntax here, and I've got to, let's see, what would be the syntax here? I guess it would be delete standard no throw like such. Maybe we should do that. And let's try to compile that. That gives us an error. Okay. So, okay, that's not the right syntax. Maybe we're in the wrong order. We only want to do something like this, right? Nope, we still got a red squiggly line here, right? So what's going on here? I mean, how do we call delete 2? Basically, guys, let me delete that. You don't. The only delete function you ever call is delete 1. Obviously, this delete as well, to delete array as well. Delete 1 array. So how do we call delete 2? Why are these here? Delete 2 would only get called in the event that the new function failed. It would be called by the compiler to call delete 2, which ultimately ends up calling delete 1 anyway. You actually never can call delete 2 directly. This is only a compiler call, and that's only if something goes catastrophically wrong. Now we can code it such that we actually end up calling delete 1, right? So in actual fact, we don't necessarily need this unless there's something really has gone screwy. And the way we're going to set things up, there's really only one way that could happen, and we'll handle it ourselves, really, if you want to know the truth. So yeah, that is the expected behavior. It is doing exactly what we want it to do. It's calling delete 1 in every instance, or the array delete 1, instead of calling delete 2. Okay, guys, so just real quick, I'm going to pull over our little design document for the memory manager. And you'll remember we came down here and we decided we needed 3 classes, one of which is a singleton. I used the word singleton there. I should change that. That's not really what we want. We want a globally accessible. That's not how you spell accessible. How do you spell accessible? Accessible interface. Okay, so we're gonna have the memory manager class. We need a memory block class, and actually, guys, I'm gonna change. I don't like this. I'm gonna change our what we're calling things here. I'm gonna call this a pool instead of a block, and I'm gonna call this instead of memory segments, I'm gonna call it a block. Memory blocks. Memory block class. And I'll probably have to change stuff up here as well. Yeah, I'm gonna have to. I probably should just do a block pool. I'm going to call it a pool instead of a block, because that more accurately describes what it is. It's a memory pool of things, and I'll go through this and make sure it's correctly labeled everywhere. Stop it. I hate that thing when it comes up because it gets right in the way. Add pool, delete pool. Pools. Add, not segments, add blocks. I don't want to get ourselves confused here, so I'm trying to fix this right in here. List of blocks. Add blocks, add blocks. This is the list of pools was right. This is blocks. Okay. I think we're good. Position in the pool. This block is defragged. Memory block. Oh, that's not spelled right. Defrag. Okay, let's save that. Memory pools. Okay. Yeah, I mean, that we don't want to get ourselves confused. So anyway, So we've got a memory manager class. I'm going to create a memory pool class and a memory block class. We need 2 more classes. So let's go ahead and just quickly put those in. We'll go ahead and project add class. Add. So I'm going to call this the memory pool class. And we'll do it again. Project add class. Whoops, that's the class was. We don't want the class without add class. And add. And we'll call this memory block class. And there you go. Okay. I'll leave it at that for now. Okay, guys. I think for right now, we'll save all this. We'll make sure everything runs okay. It should run all fine. Everything's good. No worries. So one thing I do want to say, notice in our, let's close these out. I don't need these interrupt right now. So they're just confusing things. In our memory manager class, we've got these global definitions. Nobody is calling memory manager class.h except for this guy right here. Nowhere else in the entire program does this line exist. And yet, everywhere in the program, notice I've put these in here, and it's catching these declarations. Okay? That's because these are global. This is the exact reason why, in general, you do not want to define global variables, because they exist everywhere in your program. Now, in this particular case, that's exactly the behavior we want. We want these to override everywhere in our program. And I think it'll even do it for third-party libraries if we put those in there as well. That's what we want in this particular instance. But in general, you do not declare global variables for that reason. You don't want to put stuff, out here int a like that, right? Because everywhere that's going to exist in every single one of these classes. And that's completely against the rules of object-oriented programming. You don't want that. So yeah, it's just an interesting little sidebar that even though no one ever is told to come look at this, nowhere. Global Manager doesn't, WinBase doesn't. I mean, it's nowhere, right? The only place that this actually gets looked at is from here. And yet they're still being caught by everybody. They can still see these definitions. It's just a kind of an interesting little, I don't know, thought exercise, I guess you'd call it. So yeah. Anyway, all right, guys, that's about as far as I wanted to get today, just to catch those operator new and deletes. In the next episode, we will start thinking about actually putting some code in there so that we can actually get these to do something useful. Right now, they're not doing anything. In fact, it's pretty dangerous what we're doing right here. Returning a reference to a local variable as the compiler keeps giving us warnings. We want to fix that, especially with this guy right here. Okay, and we'll start looking at that next time. So yeah, we'll stop here and pick this back up in the next video. So I will see you guys in the next one. Thanks a lot.